Alright, welcome back. So in the last video we looked at how to add and subtract rational expressions by getting common denominators. We also kind of did a short baby review of everything else. Once the due date has passed for B-Day, you will see the answers posted. So I guess that will be Thursday. Yours was due on Wednesday. Theirs is due on Thursday. So once theirs is due, I will upload the answers and you can go back and check. Okay? All right. So this time we are going to look at actually solving rational equations. So it's very similar to just adding and subtracting them because we're going to have to do that. Okay? But the whole point here is we're going to be solving for a variable. Okay, so we're going to get our common denominator, and you'll see what happens from there. So let's start with this first one. Okay, so I have a plus 1 over 5a minus 1 over a equals 1. Okay, so our very first step always with these things is to get a common denominator. So they both have an a. Those first two fractions both have an a. That last fraction, technically, is 1 over 1. Okay? So our common denominator across all three fractions is 5a. Alright? So our common denominator is 5a. So let's go ahead and fix all of them. So we don't need to fix the first one. That's still a plus 1. Over 5a. Minus, alright, we're going to have to multiply a 5 to the top and bottom of this one. So that's minus 5 over 5a. And then equals, okay, now this one over here needs both parts. It needs the 5 and the a on top and on bottom. Okay? So that's going to be 5a over 5a. All right, now here's the thing. Since all three of these fractions, every single fraction in the problem shares the same denominator, what we can do is we can multiply both sides by that denominator, and look what happens. That cancels over here, and that cancels out both of those, because you'd have to distribute this to each part. So mathematically, what we did was completely legal. All we did was we multiplied by 5a on both sides. Okay? But it's more powerful than that because it wiped out our denominator. So then we're left with a plus 1 minus 5 equals 5a. That just becomes a simple problem to solve. So we get that negative 4 is equal to 4a, and that a is equal to negative 1. Okay? So the whole point is we are getting a common denominator so that we can just forget about the denominator and move on. All right, so let's see it happen again. All right, now sometimes, and by sometimes I mean usually, you're going to have to factor these things first. So the first thing that we're going to do is factor these denominators. So I've got 6 over k still, but then minus 1 over, okay, that's going to be k times k plus 6, and that's equal to 1 over k. All right. So what that allows us to do is see which factors we have in which fractions. So hopefully it's obvious that the common denominator here is going to be k times k plus 6. So my leftmost and my rightmost just have a k. They don't have the k plus 6 piece. So what I'm going to do, just like the last one, is I'm going to multiply by k plus 6 on top and on bottom on both of these things. Whoa, maybe. Okay. So that's going to leave us with 6 times k plus 6 over k times k plus 6 minus 1 over k times k plus 6 equals k plus 6 over k times k plus 6. Okay? Alright, so we got a common denominator. Now, hopefully it's obvious, and most of you probably could have done this in the same step, but you're going to want to distribute that 6. Alright? But at the same time, let's realize that they all now have the same denominator, and we can forget about them. Okay? So I've got 6k plus 36 from distributing that, minus 1 equals k plus 6. Okay? So again, it just becomes algebra. So subtract that k over, you get 5k plus 35 equals 6. 5k then is negative 29. And then k is negative 29 over 5. Not the most nice looking answer, but who cares? It's an answer. Okay? All right, let's do a couple more, just make sure we're good, and we will call it a day. All right, over here. Hopefully it's obvious by now what you're trying to do. You're trying to get a common denominator and then see what happens. Okay? So our common denominator in this case is going to be 6n squared. So this first one needs to be multiplied by 6. So that's going to be 6 times n squared plus 7n plus 6 all over 6n squared equals, okay, this one needs an n squared. So it'll be n squared over 6n squared minus 1 over 6n squared. Okay. All right, they've all got the same denominator, so let's forget about them. And at the same time, I'm going to distribute that 6. So I'm left with 6n squared plus, what is that, 42n plus 36 equals n squared minus 1. All right, now this looks a little bit different than those first two problems because we still have a squared term. All right, but you know, hopefully by now, that anytime that you have a squared term, what you're going to do is get everything to one side and factor. So I'm going to subtract that n squared and get 5n squared plus 42n. And now I'm going to have to add over that 1, so plus 37 equals 0. Okay, gross. Let's see here. Well, 37 and 1 is pretty much our only option there. 37 is a prime number, and 5 and 1 is our only option on the other side. Now, I'm probably not going to want to do 5 times 37 if I'm trying to get to 42. Hopefully for pretty obvious reasons. Okay, so if I factor this, I have 5n, and I have just regular n. Okay, factors of 37 are 37 and 1. Probably not going to put the 37 on the right side because then I would have 5 times 37. So I'm going to want to put plus 37 here and plus 1 here. So my two answers are negative 37 over 5 and negative 1. Okay? All right. Last one. I would like for everybody to pause this video and try it. Then unpause it and see if you get the same thing as me. Alright, so if we do this, we're going to have x squared minus 2x minus 3 over x minus 3 times x plus 2 minus x over x plus 2 equals 5 minus x over x minus 3. Okay. So our pieces here are going to be an x minus 3 and an x plus 2. The farthest left equation already has both of those, so we've got to fix the other two. Okay, so our leftmost equations, function, expression, that's the word, stays x squared minus 2x minus 3 over x minus 3 times x plus 2. Okay, but this one is going to need an x minus 3. And this one is going to need an x plus 2. Okay. So all three of our fractions have the exact same denominator, which means we get to forget about it. Okay. Oh, crap. Let's try to get rid of that one. Go back to this, but I want to zoom in. Okay. So we've got x squared. Come on. This is fantastic. X squared minus 2x minus 3 minus, okay, I'm going to distribute that x and distribute the negative. So it's minus x squared plus 3x, okay, equals, that's going to have to be FOILed. So 5x plus 10 minus x squared minus 2x. Okay. So you're just left with this long, crappy thing. So again, any time that you have a squared still in it, you're going to want to get everything to one side and factor. Okay? So first of all, looking at the x squared terms, those two are going to drop. And then if I add the other one to the other side, I just have x squared. Okay? Negative 2x and 3x come together to just be the 1x minus 3 equals, okay, I got that to the other side, so that's going to be 3x plus 10. Okay, so I've got x squared minus 2x minus 13 equals 0. Uh-oh. That's not factorable. Did I do that right? Let's see. Just screaming at me if you see it. Come on, guys. Oh, this is so fun. Plus x. Okay, minus a 3 still on this side. Okay, that should be good. The other side, you're going to have 5x plus 10 minus x squared minus 2x. Oh, hold on. Oh, wait. Maybe don't hold on. That's going to be an x. Negative 4x, negative 2x. No, that's right. Negative 3 minus 10 is negative 13. Great. And make sure nothing appears wrong. I mean, we can always do the quadratic formula, but of course we want to try to avoid that at all costs if we can. But I'm kind of thinking we might not be able to. Okay. Make sure I factored all this correctly. Needed that one there. Needed that one there. It all looks good to me in this little fast look that I just gave it. Okay, well, here we go. So I've got negative b, so 2. Again, sorry if this is wrong and I made a stupid, obvious mistake, but that's kind of the downside to what we're doing right now. So I have, I can't write currently, that's fun. Oh, look what just happened. X equals, there we go. Alright, negative b, so 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 13 all over 2 times 1. Okay, so that's 2 plus or minus square root of 4 plus 52 all over 2, which is 2 plus or minus square root of 56 over 2. Okay, so square root of 56, well, that's, what, 28 and 2? That doesn't help us at all. 4 and 14? Question mark? Yep, that's right. So this is 2 plus or minus 2 on the square root of 14 over 2, which is just 1 plus or minus the square root of 14. Okay. Sorry if that is wrong. I will look back over it and make sure that I am correct. If I'm not, you'll see another video about this. But if I am right, I will not do that to you on a test, and I would hope that you'd know that by now. Okay? But the whole moral of the story is, when you're doing these things, you get a common denominator, you eliminate that common denominator, and then you just solve like